Greetings, fellow mathematicians. In this video we are going to solve an equation as square root of 2 plus the square root of x is equal to 2. Of course, we are solving it for the variable x. In order for this square root here to be well defined, x has to be larger or equal to 0. So the area in which our function is defined is a set from 0 to positive infinity, an interval where 0 is included. Now that we know our domain, we can focus on algebraic manipulations in order to solve these equations. So let's take the equation square root of 2 plus the square root of x is equal to 2. First, I'm going to show you the standard method that students use to solve this. And later I will show you the process which is much more efficient. So we are going to square this equation, and on the left side we have square root of 2 plus the square root of x squared is equal to 2 squared on the right side of the equation. So this is square root of 2 squared plus 2 square roots of 2 square root of x plus the square root of x squared, and that is equal to 4. Of course, this is by using the formula a plus b squared is equal to a squared plus 2ab plus b squared. This equation that we have is equivalent to 2 plus 2 square roots of 2x plus x is equal to 4. Now let's take everything that has x in it to the left side of the equation and everything else on the right side of the equation. So we have x plus 2 square roots of 2x is equal to 4 minus 2, or x plus 2 square roots of 2x is equal to 2. Then we get that 2 square roots of 2x is equal to 2 minus x. At this point, we have a well-known situation from theory of algebraic equations. Basically, this is a square root of polynomial of x is equal to the polynomial q of x. This is the equation of this type. So how are we going to solve this equation? Well, when solving equations of this type, we demand that q of x is larger or equal to 0. That is because a square root of anything is always a number which is positive or equal to 0. Of course, the second thing which we have to demand is that polynomial p of x is larger or equal to 0. Why? Well, it is under a square root. A square root is a function which maps positive numbers including 0 into the set of positive numbers including 0. So this p of x has to be larger or equal to 0. And the third term which we have is just solving this equation. How are we solving it? Well, we are going to put it to the power of 2. So we have p of x on the left side of the equation, and that is equal to q of x squared on the right side of the equation. So the solution of this equation we get in the form of a set where we have conjunctions of these three terms, and then final solution we are going to get by taking an intersection of all three of these sets of the variable x and the values it can take. So let's apply this concept from theory into the equation which we have. So first we demand that q of x is larger or equal to 0. That means that 2 minus x is larger or equal to 0. The second thing which we demand is that p of x is larger or equal to 0. P of x in our case is 2x. That has to be larger or equal to 0. And finally, we demand this, that p of x is equal to q squared of x, and that term we get just by putting this entire equation to the second power. So we get 2 square roots of 2x squared is equal to 2 minus x squared. this term 2 minus x is larger or equal to 0, well, it means that minus x is larger or equal to negative 2, and then we get that x is smaller or equal than 2. Conjunction 2x is larger or equal to 0, well, that means that x is larger or equal to 0. And we have here 4 multiplied by 2x is equal to 4 minus 4x plus x squared. So we have 8x is equal to 4 minus 4x plus x squared, and that is x squared minus 12x plus 4 is equal to 0. This is a quadratic equation of the type ax squared plus bx plus c is equal to 0, and the solution is given as x1 or 2 is negative b plus or minus the square root of b squared minus 4ac divided by 2a. Of course, a is 1, b is negative 12, and c is 4. So let's apply that. We have that x1 or 2 is equal to negative 12 plus or minus the square root of negative 12 squared minus 4 multiplied by 1 multiplied by 4 divided by 2 multiplied by 1, which is 12 plus or minus 144 minus 16 divided by 2, and that is equal to 12 plus or minus the square root of 128 divided by 2. This is 12 plus or minus the square root 64 multiplied by 2 divided by 2, and that is 12 plus or minus 8 square roots of 2 divided by 2, which is just 6 plus or minus 4 square roots of 2. So our equation has the solution x is smaller or equal than 2, and x is larger or equal than 0, and x is equal to 6 plus 4 square roots of 2, or x is equal to 6 minus the 4 square roots of 2. What is the solution of our equation? It is an intersection of all of these sets. This first set, this second set, and this final and third set. Let's observe the first solution. x1 is given as 6 plus 4 square roots of 2. Well, that solution does not belong in an interval from 0 to 2, which is the area in which our function is defined. Remember, we had that x is smaller or equal to 2, and x is larger or equal than 0. Well, this means that x belongs in a closed interval from 0 to 2, which is the area in which our equation is defined. So, solution x1 does not belong in this area. Therefore, x1 is not a solution of our equation. Now let's determine what happens with the solution x2, which is 6 minus 4 square roots of 2. Basically, we have that 1 is smaller than 0, and that means that square root of 1 is smaller than a square root of 2. Well, then 4 square roots of 1 is smaller than 4 square roots of 2, and that means that negative 4 square roots of 1 is larger than a negative 4 square roots of 2. And that means that 6 minus 4 square roots of 1 is larger than 6 minus 4 square roots of 2. Well, 6 minus 4 square roots of 1, that is equal to 2. So 2 is larger than 6 minus 4 square roots of 2. That means that number 2 is larger than x2 solution. So that could be in our area of definition. Now we need to prove that x2 is larger than 0. So 6 minus 4 square roots of 2 is larger than 0 if and only if 6 is larger than 4 square roots of 2. if and only if 6 is larger than a square root 4 squared multiplied by 2, that is equivalent to 6 being larger than 16 multiplied by 2, which is 32. And that is equivalent to 6 squared being larger than 32. 6 squared, that is 36, and that is larger than 32, so this statement is true. It has a true logical value, so the statement which is equivalent to it has to be true. So that means that 6 minus 4 square roots of 2, our solution x2, is in fact inside the interval from 0 to 2, which is an area of definition of our equation. And that means that this number x2, 6 minus 4 square roots of 2, is the solution of our problem. Of course, there is a shorter way to solve this problem. Square root of 2 plus the square root of x is equal to 2. You can just express the square root of x as 2 minus the square root of 2. Again, this problem is a square root of p of x is equal to q of x. And this discussion is unavoidable when dealing with algebraic equations with square roots. So to solve this equation, we demand that conjunction of the following three demands must be true. You remember the first discussion, p of x has to be larger or equal to 0. Then the second term which has to be satisfied is that q of x is larger or equal to 0. And third, we get by squaring this equation, and that is p of x is equal to q squared of x. Once we find the sets of numbers for each demand, there is one set. That set is the intersection of these three sets, and it is going to be a solution of the problem. Note that the intersection can be an empty set, and that the equation does not have any solutions in that case. So the first demand is p of x is larger or equal to 0, and in our equation that corresponds to x being larger or equal to 0. The second demand is that q of x has to be larger or equal to 0, and that demand is that 2 minus the square root of 2 is larger or equal to 0. It corresponds to that in our case, and we know this to be true statement. The third and final demand is that x is equal to 2 minus the square root of 2 squared. Now, since this number, 2 minus the square root of 2 squared, is larger or equal to 0, then this number, 2 minus the square root of 2 squared, is the only solution of the equation. Let's just simplify this. So we have x is equal to 2 minus the square root of 2 squared, and that is 4 minus 2 multiplied by 2 square roots of 2 plus square root of 2 squared. And that is equal to 4 minus 4 square roots of 2 plus 2, which is a well-known number, 6 minus 4 square roots of 2, which we got previously. So thank you for watching, and I'll see you in the next video.